So this is the end of this unit. So in number 3, function of several variables. So outline is Lagrange's method of undetermined multipliers. So these are very important chapters. So in these chapters we will get 160 mark questions or 50 mark questions. Sometimes they will be asked in the 8 marks also. So these are very important one and also important sessions. So this one is definition of Lagrange's method, application problems based on the Lagrange's method. So each and every application is very important one. So let me go through the definitions of Lagrange's method. So here is Lagrange method is based on to find the maximum minimum values, but they are also given in the constraints equations also, that is g of x comma y comma z equal to 0. So already we know how to find the maximum minimum based on f of x comma y comma z. Here is we can add one more conditions, that is a conditions g of x comma y comma z equal to 0. For this case we can use in the Lagrangian methods of multipliers. So first we can write the methods of multipliers based on the formula capital F of x comma y comma z comma lambda equal to f of x comma y comma z plus lambda into g of x comma y comma z, where lambda is called Lagrangian multipliers which is independent of x, y and z. Okay, or simply we can write capital F equal to small f plus lambda g, that is also right. That is simple notations. Capital F equal to f plus lambda g, that is also right here. Okay, so the necessary conditions for maximum minimum, you know that one, that is dou f by dou x equal to 0, dou f by dou y equal to 0 and dou f by dou z equal to 0. Here is we can add one more conditions. So this is equation number 1, 2, 3 and 4. So based on these equations we can find the maximum minimum value of the given functions here. Okay, so first we shall go through the problem number 1. So each and every problem is very important one here. So a rectangular box open at the top is have the volume of 32 cc. Find the dimensions of box that requires that least material for its constructions. So the question is, the box is given, volume is 32 cc. Here is question is, find the dimension of the box that requires the least material. That is a question here. So first here is the function is not given, instead of that one they will be given the volume of 32 cc. Okay, the rectangular box. So this is a general formula for let x comma y comma z be the length, breadth and height of the box. Then the surface area is xy plus 2yz plus 2xy, that is a surface. Then given is volume is given, we can take that one is xyz equal to 32, that is a conditions g of x comma y comma z. Instead of here is the function is based on the rectangular box open at the top. So open at the top means we can omit one value here. So 6 face means we can omit one value here. So we get the surface area is xy plus 2yz plus 2xy, or we can write 2xy plus 2yz plus xz, that is also right, or 2xy yz plus 2xz, that is also right. Okay, this is not a fixed one, we can write 3 methods to finding the surface area here. So here is I can take xy plus 2yz plus 2xz, that is nothing but f of x comma y comma z. Then condition is given xyz equal, that is volume is xyz. So volume of the rectangular box is xyz, that is xyz equal to 32 cc is given. That is we can take g of x comma y comma z. Then write the formula for Lagrange's multipliers, f equal to small f plus lambda g, that is f equal to what is small f, xy plus 2yz plus 2xz plus lambda into what is g, xyz. This one is goes to your LHS means you will get minus 32. So xyz minus 32. This is equation number 1. So be careful in writing in the equations. Okay. So next is, first find the dou f by dou x equal to 0. Next dou f by dou y equal to 0. Dou f by dou z equal to 0. That is the next case. So first dou f by dou x equal to 0. So differentiation of x with respect to the given equation is we get y, this one is 0 plus 2x, then plus here is with respect to x means we get lambda into yz. So y plus 2z plus lambda into yz equal to 0. Next dou f by dou y. So what is dou f by dou y? With respect to y means we get x plus 2z, this one is 0, plus lambda into xz. So we get, so x plus 2z plus lambda into xz equal to 0. The third one is with respect to z means, so first one is 0, there is no z here. Here is differentiation with respect to z means we get 1, so 2y plus here is 2x plus lambda into xy. So that is a next one equal to 0. So for this case I can write y plus 2z equal to minus lambda yz. For this case I can write x plus 2z equal to minus lambda xz. For this one is 2y plus 2x equal to minus lambda xy. So try to equating the any one side must be equal for all the equations. So then we can able to find the solutions easily here. So next here is I can divide by yz here. So y plus 2z divided by yz equal to minus lambda. Similarly here is x plus 2z divided by xz equal to minus lambda. For this case 2y plus 2x divided by xy equal to minus lambda. So here is all the equation must be equal here. So first I can take, here is I can divide by y here. So here is I can divide by y means we get 1 by z, plus here is I can cancelling z here, so we get 2 by y equal to minus lambda. Then cancelling x here we get 1 by z, plus I cancelling z we get 2 by x equal to minus lambda. For this case I cancelling y here, so we get 2 by x, plus I cancelling x here, so we get 2 by y equal to minus lambda. So equation number 2, equation number 3, equation number 4. So we can find one by one. So first I can take from 2 1 to 3. Your RHS must be equal. So therefore 1 by z plus 2 by y equal to 1 by z plus 2 by x. So cancelling 1 by z, 1 by z, the remaining value is 2 by y equal to 2 by x. Then cancelling 2 to here, then take the reciprocal x equal to y. So we get 5 here. So next I can take 3 and 4. So equating 3 and 4 we get 1 by z plus 2 by x equal to 2 by x plus 2 by y. Then cancelling 2 by x and 2 by x, then we get 1 by y equal to 2 by y. That is, take the reciprocal or cross multiplying this one. So here is y equal to 2z. That is equation number 6. Then using 5 and 6. So next using 5 and 6 we get x equal to y equal to 2z. That means here is x equal to y, y equal to 2z. So you can replace x equal to y. What is y here? That is 2z. So therefore x equal to y equal to 2z. So we know these are final equations. Next we have to find the value for x, y, z by substituting this one in the given conditions. What is the conditions? Volume equal to x, y, z equal to 32. So we can replace any one of the values here. Or I can replace x equal to 2z, y equal to 2z. You can keep z as it is. So everything in terms of z form. So x equal to 2z, y equal to 2z. So we get equal to 32. So multiply these three values, we get 4z cube equal to 32. Therefore z cube equal to 32 by 4. So answer is 8. Therefore z cube equal to 8 means what is z? Z equal to 2. Substitute z equal to in the equations, x equal to y equal to 2z. So what we get? So z equal to means we get 4. So y equal to 4, x equal to 4. Therefore x equal to 4, y equal to 4, z equal to 4. So these are dimension of the box are 4 comma 4 comma 2. So this is a very important problem. Okay, be careful for finding the solutions. Again I can recall here, the rectangular box open at the top means first we can find the functions here. Here is functions not given. So the surface area of the rectangular box is, one is open means we can take xy plus 2yz plus 2xz equal to f of x comma y comma z. Have a volume is given. Volume is, that is a conditions. So 32 cc. The volume is nothing but xyz. So xyz equal to 32. Therefore that is another equations. Substitute this one is in the Lagrange multipliers. Next we can find the equations. Dou f by dou x equal to 0, dou f by dou y equal to 0, dou f by dou z equal to 0. So finding this one, then find the value for using three equations. So we get x equal to y equal to 2z. Then substitute this value from the given conditions, we get the value for x, y, z. So this is a very important problem. So be careful here. Okay, we will continue the next sessions. Thank you.